All right, this is the combined gas law. And all the combined gas law does is combine Charles' law V2T2 with Boyle's law and so what we're going to get is P1 V1 over T1 equals P2 V2 over T2. Okay? And we just solved one of these problems a moment ago. All right, so number 25 on page 26 of a unit handout is a combined gas law problem. And you use the same process I've taught you already to solve these. All you have to do is make out your list of knowns and unknowns here, and you'll find you'll have V, P, and T as your variables. Well, if V, T, and P and V1, T1, P1 and V2, T2, P2 are the knowns and unknowns, then that fits this combined gas law here. You simply plug it in and solve it exactly the same way we did before, only now we got two things to cancel out over here instead of just one. Okay? It's really very simple. Use the same solution process. Got it? All right. So, and that's it. Don't make this hard. It really is just that simple. If you use the process I've taught you, it's just that simple. Okay. Now, let's look at the ideal gas law. This gets a little more sticky. All right. There are different versions of the ideal gas law. If you get out your test references, and everybody should have those out already, we said previously that all of the gas laws are right in here in your test references. Okay? They're all right in here. Okay? This is the traditional form of the ideal gas law. But this and this are other forms of the ideal gas law. And all we've done is to take density and molar weight and figured out a way to use those in this law to get these. So we can actually take and derive these equations from that. All right? I don't want to spend a lot of time with that in here. In fact, there's a video on the website already that goes through that derivation, or those derivations with you. And it's not really that hard, but it's just a little bit of algebra. Okay, just a little algebra. Okay, but for right now, let's just stick with just the ideal gas law within the traditional form, where pressure times volume equals N R T. So we've already previously defined P as pressure, V as volume, and T is temperature in what units of measurement? Kelvin. Temperature always has to be in Kelvin for gas law problems. Okay? So these two variables right here are new things maybe. Okay? N. N means the amount of gas. N means the amount of gas. All right. Candy bar for anybody that can tell me what the SI unit is for the amount of substance. Candy bar for anybody that can tell me what the SI unit for the amount of substance is.
APM. MMHG. Wait,
U1 equals V2.
What? No.
What is the question? What's the SOS?
This is from Unit 1.
Oh,
It's the SI unit for the amount of substance, and that's what we're doing here. It's the amount of gas. Well, who said moles first? I said first. I think it was Thomas.
I said moles.
Oh yeah, Thomas gets to choose.
Yeah, I accidentally killed
Why are you mad?
Because I want to kid.
Well, I'm sorry.
That was a smart little thing, though.
All right.
I don't get a product.
Moles is the way we measure the amount of substance. Okay? So, in the ideal gas law, N is what's going to stand for moles of that substance. Just like P stands for pressure, T stands for temperature, and V stands for volume. Okay? So this is going to be measured every time, all the time, in moles. Okay? Let's see. Now, R. R is a special kind of gas constant. Remember we said when we're looking at Charles' law, V over T is equal to some constant, and from that we derived this equation to do our math problems. And for Boyle's law, P1 or P times V equals some K. And the K's over here are some constant. Well, this R is a special constant. It's so special we give it its own letter. Okay, so R is the ideal gas constant, or simply the gas constant. Okay? So if you hear me say the gas constant, that's what we're talking about. Now you need to get out your test references. Get out your test references. Okay? And on the very first page, you'll find R. On the very first page of your test references, you'll find R. If you have them still stapled in order. If not, it's the one that has that at the top.
It's right there.
There you go. Okay, has everybody found it yet? All right, notice there are 6 different versions of R. So the only real tricky part, and it's not that hard, is you have to find all of your knowns and unknowns and match R's, these units of measurement here, these measurement units here, to the other variables in your problem. That's all you have to do. Okay? And we'll practice with this to try and learn how that works, okay? All right. So, now, here's something that students tend to mess up on a lot. So let me give you a heads up about this. What I'm going to tell you, don't do. What students will do is they'll look and say, okay, this is 0.08206 liters, atmospheres, Kelvin, moles. And they'll plug into this fraction their volume of gas and their pressure of gas and the Kelvin and the moles. You don't do that. These are not variables. These are units of measurement. You don't plug in numbers into that. These are units of measurement, not variables. Okay? Yes. Yep. What you plug into is this equation. Okay? You plug into this equation, not this. All right. So let's find this. Let's make up a gas law problem. Okay? Will, you with us back there? Forrest, you with us back here? Okay. All right. All right. So let's just make up a problem. Let's say say what?
Thought his name was Dick.
Well, he said Dick, and you guys calling Forrest. I don't know.
I call him Dick.
Okay.
Forrest.
All right.
Yeah, they call it, Richard.
There you go. We did what you do on and I'm just saying, y'all can call me all kinds.
Hey, there we go, man.
Where's it right here? Oh. 'Cause I remember this. So, 1 times 10 to the 9 joules. 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 far as they got anybody in this class?
What is that?
What you said?
We got three so far.
I said, how far as practice got anybody in this class?
Yeah, actually, I could be saying.
Okay. Everybody got it written down? You turn this down.
You just realized.
Yeah, it is. But that's the point, isn't it?
What's that between volume and 0.2? What's the
Is?
We're using that formula right here.
Well, let's find out. Okay. All right, let's make out our list of knowns and unknowns. Make out a list of what you have. Read your problem, make out a list of what you have. Got to have our temperature in K. Okay, all right, so we got volume, pressure, and temperature, and it's asking you for the amount of gas. And how do we measure amount of a substance? Who said that? I was hoping somebody else was going to be a little faster this time. I had some more candy to give away. All right, so we're looking for N then, aren't we? Because N, moles, is how we measure the amount of a substance in chemistry or physics. Okay? So that's what we're trying to find. Now, that's not everything we need for the ideal gas law, but here's the thing. You always have the gas constant. Okay, do you get this? Everybody hear me?
Yes.
You always have the gas constant because why? It's in the references. It's right there. You always have it. So R we always have. Now we've got the ideal gas law. You just have to figure out which one to use. And we got 6 choices. All right, let's look and see if we can figure out which one to use. I've got liters, I've got atmospheres, and I've got Kelvin. All I have to do is find the version of R that has those same measurement units.
Wouldn't it be the first one?
Yes.
Because
Yeah, I kind of made it easy for you the first time. Okay? It's the one right there. Right? Liters, atmosphere, Kelvin, and we're trying to find moles. Does that make sense? Almost all the time, not every time, it's not guaranteed, but almost all the time, you just have to match up the unit, in chemistry anyway, you're going to match up the units we have here for pressure. Atmosphere, millimeters of mercury, kilopascals, or torr. We almost never use these in chemistry, at least not in high school chemistry. What?
Is it some new law?
Yeah, this is the ideal gas law. Okay? All right then. So R we have, and we know that because it matches up with the units we have, it's 0.08206 liters times atmospheres over Kelvin times moles.
Oh my God.
All right? What?
Oh my God.
I'm sorry.
Oh my God.
Okay, so we do have all the variables, all the parts to the ideal gas law here. So we can write down PV equals nRT. Just like before, we're simply going to pick out the gas law that fits these variables. Huh? And you always have R. So if you don't have R and you need it, you always have it. All you gotta do is find it. Okay? It's not hiding. Alright, so we just plug in your knowns and unknowns. So start plugging in your knowns.
What is that?
Do that now. Start plugging in your knowns.
What's that last number?
Which one here?
8206 something.
Now,
L?
Oh, that's liters. Okay. It's right here on your test references. So plug in your knowns, please. You can do this. Plug in your knowns.
Is that P because they're not P?
That's the ideal gas law. And it's on your test references too. Okay? All right, so let's see. We got a pressure of 1.05 atmospheres. We've got a volume of 0.25 liters. N we don't know. R we know. It's going to be 0.08206 liters times atmospheres over Kelvin times moles. And we do have a temperature, 298.2 K. Okay. All right.
oh, so this is,
Now we just got to solve for N. This is a little more sticky, but it's just manipulation, just like you learned to do in algebra. Okay? I'm going to leave this one with you for home. Let's see. We get out of here at 11:30, right? 11:33? I'm going to leave this one with you to let you do this for homework. Okay? I'm going to see if you can try to figure out how to do it. All right? It's just simple algebra.
So you multiply and then the value.
Remember, the next step after you plug in your knowns is to isolate your unknown. You're going to isolate your unknown. Okay? How are we going to isolate the unknown? What do you got to do? Same process. It's just more complex because we got these complex sort of fractions over
so
here.
each time, instead of talking times each other by each side, so basically that side you're going to be like 1.05 times 0.25.
But then you have to multiply both sides by the reciprocal of these two things to cancel them out.
So what times are on each side, or what times are we on?
You got to get the n by itself, don't you?
Yeah.
If you're going to get the n by itself, then you've got to multiply both sides of the equation by whatever will get n all by itself. And you do that by multiplying by the reciprocal, the flip of this and the flip of that. You got to multiply both sides by that. So you're probably going to need to take some paper and turn it sideways to do this math. Okay?
Up there, does it say R equals the 0.0 thing, or is it R times?
R is equal to. That's the gas constant. Okay?